Hello students, I'm going to give you a quick little compare and contrast involving completing the square because in my past students get often confused like why would I complete the square to solve and graphing, or like what's the difference? What's the difference between the two? And it's just good to know. First, let's take a look at this. We can complete the square to solve a quadratic. Notice this equation. Do you see how it's equal to 0? And do you see any y? If that is the case, then you know that you're not going to graph this. You're going to use algebra to actually solve this equation. And I'll do that for you in just a minute. If you ever were asked to graph something from the vertex form, to get it into the vertex form, which is y is equal to a times x minus h quantity squared plus k, then you would complete the square. But you see how you have your y there? You're not going to solve anything. You're just going to change the form and then you can graph it. All right, so let's go back here. So if you were asked to solve this quadratic equation by completing the square, let's go ahead and run through this. So this is a review, but I think it's good to see these two methods side by side. So we've got x squared minus 10x, and then the perfect number that we need there is half of 10 squared, which is 25, right? What about this 7? Well, we can kick that 7 to the other side, right? And maybe I should have written it over here first. When you added your 25 in here to keep the equation equal, you're going to add the 25 on both sides. So far, so good. Now we are going to factor this, write this as a binomial square, a perfect square. Combine those two. 25 minus 7, I think that's 18. And then now to solve this, we would square root both sides. This becomes x minus 5, and this becomes plus or minus the square root of 18. We're still solving for x, so we have to add 5 to both sides. And we get x is equal to 5 plus or minus the square root of 18. We would never leave this. We would break this down into 9 times 2, which becomes 3 square roots of 2. So our answers would be 5 plus or minus 3 square roots of 2. And what we have found are the two numbers that make this quadratic true. There are two solutions. All right, over here, when you have the y, we're not going to add the perfect number to both sides. Remember, we're going to work strictly on one side of the equation. So I have y is equal to x squared minus 10x. We're going to push that 7 over. We already know that our perfect number is 25. So if we add 25 in here, we're going to subtract 25. Now let's write this in factored form. X minus 5 quantity squared minus 18. Now we have this in vertex form. And if we wanted to graph from here, our vertex would be the point 5, comma, negative 18. Let me kind of make my graph like this. 3, 4, 5. I don't know if I can get 18 on there. If this were a 5, 10, 15, 18 would be about there. And our A is 1, so we're going to go over 1, up 1, over 1, up 1. And our graph would look something like this. Do we know what the solutions are for this? Only if we kept like just kind of sketching. But remember, to solve a quadratic by graphing is a big, well, I can give you a rough estimate maybe if I use graph paper. If you wanted to see what the answers were, you could actually figure out an approximation using your calculator. 5 plus 3 times the square root of 2 is going to be around 8-ish something. 5 minus 3 times the square root of 2 is going to be between 1 and 2. So yeah, wasn't too bad there. Did a pretty good job. So anyway, so that's compare and contrast the two methods, solving using completing the square and graphing using completing the square. I hope that helped.